Hi, I'm Joe Calandrino. I'm a new assistant professor in the School of Computer Sciences, Software and Societal Systems Department, as well as the College of Engineering's Department of Engineering and Public Policy. I'm also affiliated with CMU's Scilab Security and Privacy Institute. My research falls at the intersection of computer science with public policy. I apply computer security, privacy, auditing, and related research methods to explore socio-technical systems. Before joining CMU, I conducted research and used my technical expertise in the policy and legal space for a number of years. And that experience really heavily influenced the goals of my research and the questions that interest me. As a result, my aim is to use technical research methods like those I mentioned earlier to inform policy discussions and advance policy objectives. As an analogy, I see my role as being like public health researchers whose rigorous scientific work informs health policy and may identify novel interventions. But instead, I'm seeking to conduct computing research relevant to critical and timely policy issues that involve technology. Work like this can seek to accomplish a number of goals. For example, it can help uncover possible issues, to understand the nature of an issue or its impact, or to suggest technical remedies or effective policy interventions for a problem. Similarly, the forms of research that you might conduct here also vary dramatically. For example, you might conduct technical measurements, reverse engineer a system's operations, or examine how people behave and what they expect when interacting with a system. But as is often the case with research, the tools that you use really depend on the question you wish to address. Given the breadth of work in this area, I won't throw tons of projects at you, but I thought I'd share a recent project exploring privacy settings of third-party libraries that developers incorporate in Android apps as an example of a policy-relevant research topic. So many mobile apps are heavily comprised of third-party libraries. These libraries can do everything from facilitating ads in the app to incorporating social networking features, saving developers tons of time and effort as they're building their apps. When you look at privacy and security issues that arise in mobile apps, a topic that's drawn considerable attention in the policy space, many issues ultimately trace back to third-party libraries in those apps. These libraries often come with settings that developers can choose, and these settings might have default choices. For example, a library might have a setting that allows developers to choose whether or not to collect certain data, and the library might collect the data by default unless the developer changes the setting. We wanted to explore whether a link might exist between default settings choices in third-party libraries and privacy issues that arise in apps that incorporate those libraries. To examine this, we built technical infrastructure to analyze apps' data practices and to answer questions like whether those practices differed from the app's claimed practices, and if we could trace the problem back to default settings of third-party libraries. We might look at, say, whether the app claims not to collect certain data, but the app did collect the data because of the settings of a third-party library in the app. After building that infrastructure, we analyzed the large number of apps that incorporated some popular third-party libraries. I won't get into all of our findings here, but let's dive into one of them. We uncovered nearly 1,700 apps incorporating one popular third-party library. Of those apps, we uncovered a particular privacy issue in nearly a quarter of the apps that stemmed from a third-party library's code. Basically, the apps were sharing a certain identifier without disclosing that sharing as they were supposed to do in the app's privacy label. The third-party library had a setting allowing app developers to choose whether or not to share this identifier, and the default choice was to share. For about 40% of the problem cases we observed, or about 10% of the apps overall that incorporated this third-party library, which was nearly 170 cases, the setting was untouched. So the app was sharing this identifier due to the default setting. Now, some developers may have been aware of the default and intentionally left it unchanged, but others may have been unaware of the setting or reluctant to change it. So why does this research matter from a policy perspective? In general, policymakers might seek to address issues like those I discussed by encouraging individual developers to change their practices for each of these nearly 170 apps with suspected issues. Our work suggests that a more effective intervention point might be to approach the developers of third-party libraries and encourage more cautious default settings choices. It's possible that a more cautious approach would have avoided issues in 170 apps all at once in this particular case. And that's just one example of the type of work that I like to do. If this work is of interest to you, please feel free to reach out to me. I'd love to chat. Thank you.